Very often in 3D CAD modeling, there is more than just one way to obtain the desired shape. This tutorial is meant to show you two possible workflows to achieve a desired shape, and we will take this opportunity to do a small discussion about the differences of the two workflows and the advantages and disadvantages of each workflow. Quite often in 3D CAD modeling, there is more than just one way to obtain the desired shape in 3D. This tutorial is meant to show you two possible workflows to obtain the desired model, and we will talk about the advantages and disadvantages of both workflows. The version of FreeCAD used here is a 0.16 development snapshot on a Windows 7 64-bit system. FreeCAD is under continuous development, and on a nearly daily basis changes are applied to the source code, correcting bugs and introducing new features to the software. From time to time there is some sort of feature freeze and a release version is being made. The latest stable release at the point of making this video is the 0.15.4671 release, which means that the source code from the beginning received 4,671 changes. Now if we take a look at the FreeCAD homepage and click on download, we will have our official stable installers and we will have our development versions. For Windows and Mac OS X users, you can click on the link for the FreeCAD Files page, taking you to a GitHub repository where you can download the newest development snapshot for Windows and for Mac OS X. With Windows you have the choice of downloading a 64-bit development snapshot or a 32-bit development snapshot. You don't need to download the source codes. So as I said, the latest stable release, is the 0.15.4671 release. And if you take a look at the version numbers here, the latest development snapshot is at the moment of making this video the 0.166114, meaning we are already some sort of 1,500 commits to the source code ahead of a stable release. A lot of bug fixes, a lot of feature improvements, and there is really nothing negative in using a development snapshot. With a development snapshot, you have a 7Z archive under Windows and no exe installer. So you just download the archive and unpack it to a directory of your liking. And if you do not have the 0.15 stable release already installed on your computer, there is no problem under Windows to install several versions of FreeCAD parallel. You must make sure that depending on your version, for the 64-bit version, you must have installed also the Visual C++ redistributable package for Visual Studio 2013. And for the 32-bit version, you have to install the 2008 Service Pack 1 Visual Redistributable package on your system. When using Ubuntu, Linux Mint, or any other Debian-based Linux distribution, you have the option to change to the daily PPA instead of using the FreeCAD version from the systems repositories. As you can see here on the download page, with a chapter Ubuntu PPA packages, you should make sure that you do an upgrade of your Linux version to the latest version available. And then you have to add this PPA address, freecad -maintainers / freecad -daily, to your system software sources, either using the terminal or using the GUI. And then you should be able to update to the latest FreeCAD development version. So let's begin with our lesson. First, let's do the ball bearing with using the part workbench. The modeling strategy will be first creating the outer ring, then creating the inner ring, then modeling the groove, and then adding the balls. So let's close these documents. Let's create a new empty document and make sure that the part workbench is selected. First of all, we will add a cylinder, and we will apply to the cylinder with the data tab values for the radius to be 11 millimeters, and the 8 should be 5 millimeters. Okay, we will switch to axometric view. We will zoom outwards to fit all on the screen, and then we will insert a second cylinder. The second cylinder will get as values for radius and 8 a radius of 9 millimeters, and the 8 will be left at 10 millimeters. We will apply a placement to the second cylinder in Z direction minus 2,5 millimeters. As I've said before in other tutorials, when doing a Boolean operation, like this time we want to do a cut on these two cylinders, it is better to have overlapping contours than to have coincident faces. It is not in all cases necessary, but if you have the ability, please do so, it is better. So we will mark the cylinder. We will hold down the control key to also highlight the second cylinder. We will apply a Boolean cut, and we just made the outer ring. The next operation is to insert another cylinder and to apply to the cylinder a radius of 6 millimeters and an 8 of 5 millimeters. We will add a fourth cylinder, giving the fourth cylinder a radius of 4 millimeters. The 8 we will also leave with 10 millimeters, that's okay. And we will also click on the placement tab and click on these three small dots here to apply a placement in Z direction of minus 2,5 millimeters. We will also now highlight the cylinder 002. We will press down the control key and also highlight the cylinder 003 and also apply a Boolean cut here, and we've just made the outer and the inner ring of the ball bearing. So the next step is to apply a fusion to these two objects. So we highlight these two objects and apply our fusion. To get our groove, we will insert a torus. We will highlight the torus, and we will change radius 1 to be 7,5 millimeters. and we will change radius 2 to be 2,25 millimeters. We will apply a placement to the torus in Z direction of 2,5 millimeters. As you can see here, the torus just reached the desired position in 3D space. So then we will highlight the fusion, we will highlight the torus, and we will apply a Boolean cad, and we just received our groove. The next thing is to insert a sphere, to highlight the sphere, and to apply a radius. The radius applied is 2,2 millimeters. When we will apply a placement in Z direction to be 2,5 millimeters, and I will choose the Y direction. I could also choose the X direction, and I will apply a value in Y direction of 7,5 millimeters. As you can see here, the sphere just reached the desired position in 3D space here in the center of the groove. I will click on OK. As you have realized, the sphere is a little bit smaller than the groove. If the radius of the sphere would be the same as the radius of the groove, you would get difficulties in doing a Boolean fusion on all objects, because the geometry core used by FreeCAD doesn't handle very well such a coincident and in this case co-radial phases. On the other hand, if you just want to achieve a technical abstract representation, if you say you need just an abstract model, not a wet realistic model, you could decide not to apply a groove here. You will just stay with your two rings and your sphere here and your array. In this case, you would have overlapping phases, and you would have no problem in doing a Boolean fusion on those objects in such a case. This is something not to be easily decided, and you will often reach such a point of decision in 3D modeling. So we will now highlight our sphere. We will change to the draft workbench, apply our array, and we will change the array type from auto to polar. We will change the number of polar copies to be 10. And since the standard axis for the polar array, which is inserted, is the z-axis, we do not change the values here or any other values. We just click in empty space and FreeCAD updates our model. We will apply a Boolean fusion on these two objects, so we switch back to the part workbench, apply our fusion, and here we go. We've just finished our ball bearing. Now let's do our ball bearing model with using the part design workbench. The workflow will be similar, but we'll use different tools. And the idea is again to first do the outer ring. The sketch will already contain 1/2 of the groove, and then we will model the inner ring with the second half of the groove, and then we will model one sphere, and then we will do our array. So let's begin. Let's close these two documents. Let's create a new empty document, switch to the part design workbench, switch to the model view. Let's create a sketch on the YZ plane. Let's use the polyline tool. Let's start here, doing a vertical line which reaches the horizontal axis. Then do a horizontal line, do vertical line, horizontal, vertical again. Do a right click to end the tool polyline. Now we have an over-constrained sketch. In this case, one of these three constraints should be deleted because this is the over-constraining. I will choose this one to be deleted. So I highlight this constraint here and press delete on keyboard, or I could also do a right click here and select delete. That would have the same effect. So now we are no longer over constrained, we are under constrained. So let's do an arc element from this point here to this point here. Okay. Now the next thing is to apply equality to these two lines here and apply equality to these two lines here. So the next thing would be to select this point here and select this origin here and apply a horizontal dimensional constraint of 7,5 millimeters. The next thing would be to select these 2 points here and apply a horizontal dimensional constraint of 9 millimeters. When we select these 2 points and apply a horizontal dimensional constraint of 11 millimeters, we select the arc to have a radius of 2,25 millimeters, and we select this line here and apply a vertical dimensional constraint of 5 millimeters. Now the sketch doesn't look right, so let's go backwards one step and apply again 30 millimeters. Let's change the value to 20 millimeters. The sketch does look good. Okay, let's try to change 15, 10, and the third step 5 millimeters. Okay. This is a common thing within FreeCAD. If you apply a change to a value which is too big, the sketch could end up in another possible mathematical solution, but an unwanted one. So as you have just seen, I played a little bit with the sketch and the constraints. I went back one step and applied the dimensional constraint again. And then I did change the dimensional constraint not in big steps but in smaller steps and ended up with a correct sketch here. So I close the sketch now and I apply my revolution. The vertical sketch axis we will use, that's okay. And here we go. So now we will apply our second revolution to get the inner ring. So let's do a right click on the revolution here and either choose hide selection or choose the toggle visibility option. So I will choose hide selection and then I will apply a new sketch on the YZ plane. I will just draw a profile like I did before, doing a vertical line here, horizontal one here, vertical one here, horizontal line here, and another vertical line here. Then I will create my arc from this point to this point. I will apply equality to these two lines. I will apply equality to these two lines. I will apply my radius here of 2,25 millimeters. And I will then apply here my horizontal dimensional constraint of 4 millimeters. I will apply here a value of 6 millimeters. I will apply here a horizontal dimensional constraint of 7,5 millimeters, and I will apply here a vertical dimensional constraint of 5 millimeters, and we're all set. I will close the sketch. I will do my revolution around the vertical sketch axis. I will choose OK. I will toggle the visibility of the outer ring here. And as you can see, we just obtained our two rings with our groove. So let's do the sphere. We highlight these two revolutions, apply a right click and toggle the visibility. We click in empty space to deselect everything. We apply a new sketch to a YZ plane. We click on OK, we zoom a little bit in. We will do our arc, starting here, going from here to here. We will create a line from the endpoint of the arc to the other endpoint and applying a vertical dimensional constraint. We will then apply another line from this endpoint here, just going down to the horizontal axis, and we will toggle the line to be of construction type. We will then choose the midpoint of the arc and this line here and apply a symmetry. We will apply a radius to the arc of 2,25 millimeters. We will apply a distance here of horizontal dimensional constraint of 7,5 millimeters. And we will apply our vertical dimensional constraint here of 2,5 millimeters. And in this case, the auto constraining did not work. We will constrain this point here to be onto the horizontal axis. Now we are all set. We close the sketch. We do our revolution, but we will not choose our vertical sketch axis. We will choose sketch axis 0. Okay. And now we have our sphere here. We will also apply our array, and we can't apply a polar pattern feature because the polar pattern feature is only meant to be applied to pads or pockets within the part design workbench. We have one single solid, and we want to apply some sort of an array to it, so we have to use the array tool from the draft workbench. So we highlight the revolution here. We switch to the draft workbench and we do our array. We switch again to polar type. We change the number of copies to 10. And here we go. We toggle the visibility of these two revolutions. And we could now do a fusion on all these three objects. And so we have also created the ball bearing using several sketches. So as you can see, both workflows have their advantages and disadvantages. If you will change later one of the dimensional values, for example, it is, in my opinion, a little bit easier to just search for the right sketch and then to enter the sketch in edit mode and apply a new dimensional value to one of the constraints, then to search in the part workbench for the appropriate primitive and change its placement or whatever. But of course, it is easier to apply the draft move and rotate commands to a part created within the part workbench. With the part design workbench, you have to apply the move and rotate commands to the sketches you used, namely to the first sketch you have used. And of course, with part design, maybe you will take a little bit longer, speaking of the time needed to do the model. But on the other side, if you use the part workbench, you noticed that we had sometimes to switch to the draft workbench or to the sketcher workbench maybe, and to use some tools from there. So this is also a little bit more work. As I said before, there is no single and no only real one way to do a model in 3D space. There are often more than one ways to do a model, and depending on the purpose of your model and the shape of your model, maybe you will be forced to use a specific workbench for your purpose. As you have seen, we did switch workbenches quite often, and every time we used the pull-down menu. On my personal system, I use a little trick to speed up switching between workbenches. Now, since FreeCAD is programmed mostly in Python, if I also enable per view the Python console, and let's say if I will switch to the part design workbench, you can see in the last line of the Python console the Python command used to activate the workbench part design workbench. So I did record a macro using the record button, switching just to one of the workbenches, and then I stop the recording. And for example, the macro used to switch to the sketcher workbench does look like this. I use this button here, execute macro. I select my macro, which is named here wb underscore sketcher dot fc macro. And if I go to edit, you will see that it just contains one line activating the workbench sketcher workbench. The next step was to use the tools customize menu to go to the category macros and to apply to each just recorded macro. In my case, I recorded 4 macros to switch to the sketcher workbench, to the part workbench, to the part design workbench, and to the draft workbench. I applied here a menu text, a tooltip, sort of short help and a keyboard shortcut. And I also applied an icon to this macro. The next step would be to define a global toolbar. So I went to the toolbars and selected here from the drop-down menu the global section, and then I created with new a custom toolbar. And the custom toolbar contains now all of these 4 macros. And if I tick this box here to make the custom toolbar show up, and I click on close, I have to restart FreeCAD to apply the changes. So after restart of FreeCAD, my custom toolbar shows up, and within the preferences I have set the initial workbench to be activated to be at startup the complete workbench to make sure that everything I have set up as user customization will be added to FreeCAD. And so this is my custom toolbar showing up in every workbench, and I quickly can now switch to the Sketcher workbench by clicking on the icon here. I just switch to the Sketcher workbench or using the designated keyboard shortcuts. So, well, speaking about different ways of doing a CAD model, and speaking about efficiency and parametric and history and things like that, well, what about adding a bonus lesson? So let's jump aboard our time machine and head right back to the first lesson we did, the Turner's Cube. At the time when you did the Turner's Cube as a first lesson, the main point of the lesson was to get you familiar with the pad and the pocket function. And so some users ask one of the first obvious questions: is there a way to duplicate or reuse the sketches to get a more efficient model? Of course, this is possible. We learned during the lessons that you could reuse the sketches by copying them, for example, to the clipboard and inserting them somewhere else. And you can also reorient the sketches and attach them to other faces. This is possible. But as you can see, we used a lot of pockets, and those pockets all have the same dimensions. The big pockets have the same dimensions, and the middle pockets as well. And speaking of an efficient parametric 3D model, this way of modeling is not an efficient modeling. But this is quite common after some time if you learn new tricks and maybe the software did get 1 or 2 new features. If you look then at your CAD models, you will not be the first one to say, oh dear, what did I do there? Let's throw the model into the digital trash and redo everything again. So if we will set up a task saying, let's do a Turner's Cube using the part design workbench and use a parametric modeling using as few features and as few dimensions as possible, this would look like this. So let's close this document, create a new one, switch to the part design workbench, and the first thing we did was creating a new sketch on the XY plane. We created a rectangle. We applied symmetry to these 2 points in regard to the y-axis, and we applied symmetry to these 2 points in regard to the x-axis. Then we applied equality to these two lines, and we applied a dimension of 200 millimeters to this line here. There is nothing to optimize here. So we close the sketch, we do our pad, we do it symmetric, we change the dimension value to 200 millimeters. Okay, the first operation, the pad, there is nothing we could do to optimize that. There's only one thing which is missing at the moment. We would like to be able to set in this case an equality constraint or something similar between the dimension used in the sketch and the 8 of the pad we defined with 200 millimeters and being symmetric. At the moment this is not possible, but I've read in the forums that with the 0.16 development snapshot something called expressions is introduced, and if I understood all the postings were correct, now this is also possible to set up relations between constraints in different sketches and constraints used on operations like this. So the next thing would be our pocketing. We would not use several single pockets to make an efficient parametric model. We will use a revolved profile and an array, and then doing a Boolean cut and using clones to get the rest to pockets. So now let's toggle the visibility of the pad, apply new sketch, in our case now to the YZ plane. Let's use the polyline tool, start on the vertical axis here, go upwards, and then apply our 3 pockets. Like this. We now have an over-constrained sketch, so we will delete this constraint here. We will apply equality to these 3 lines. Because this dimension we will set up with 25 millimeters, and this dimension we will also set up with 25 millimeters. So now we will set up the radius of the 3 pockets, the biggest one being 93,75 millimeters. The next one is oops, I selected 3 points. Now let's select this point and this point, applying a horizontal dimensional constraint of 62,5 millimeters. And let's select these 2 points, applying a horizontal dimensional constraint of 31,25 millimeters. That's it. We close our sketch, we do our revolution, and here we go. The next thing would be to switch to the draft workbench, have the revolution highlighted, and then doing an array. Make sure the array is highlighted, change the array type from auto to polar, change the number of polar copies to 4, and change the axis to be not the z-axis. In this case, the axis of a array, of a polar revolution, if you will call it like that, will be the x-axis. So let's change the value for the x-axis to 1 and change the value for the z-axis to 0 back. Now we will have something like this. We will set the fuse parameter to true to obtain not 4 overlapping solids, but one single solid. Okay. So the next thing is that we will highlight this revolution here and do a draft clone of the highlight revolution. We will use the clone of the revolution and do a placement. We will change the placement to be incremental. We will choose the y-axis as rotational axis, and we will apply a rotation of 90 degrees. We will then clone the revolution again, this time applying to the clone an incremental placement. We will change as rotational axis the y-axis, but in this case we will apply minus 90 degrees. We click on apply, choose OK, and this is one of the limits of FreeCAD at the moment. It is of importance at which point in the history of a part you did do the clone. If I will change the sketch or the revolution at some point, the clone will also change. But if I will add something to a revolution, the clone will not change, because the clone was made in a point of history of a part when only the revolution existed with the sketch. So let's select the array, the two clones. Let's switch to the part workbench and do a fusion of all these solids. Let's toggle the visibility of the pad. Let's select the pad and the fusion, apply a Boolean cut, and we have made our Turner's cube. As you have realized, we only used 200 millimeters here as dimension, 200 millimeters with the pad, and our few dimensional constraints with this one revolution. So this would be a very efficient way to use the part design workbench and design a Turner's cube. The Turner's cube is parametric. You can change your values, and it is history based. You can go back in the history of creating the part. Well, with that being said, we have reached the end of today's lesson. I hope I did show something useful and you had fun learning new tricks with FreeCAD. As usual, feel free to leave any comments, critiques, remarks, requests or something like that related directly to the video here on YouTube. Or if you have more complex questions, feel free to register for free with the forum on freecadweb.org and upload snapshots and post your questions there. I hope you will enjoy working with FreeCAD, and well, maybe see you on another video. Bye!